Both real and imaginary numbers can be multiplied times real and imaginary numbers. Here's what I mean. Let's say we have a complex number 3 minus 6i. We can multiply it times 2, a real number. We multiply 2 times the real number 3, and that gives us a real number 6. We multiply 2 times the imaginary number, negative 6i, and that gives us negative 12i. So we can multiply a complex number times a real number, and the product is a complex number. We can also multiply a complex number by an imaginary number, such as 2i, giving us 2i times 3, which is 6i, an imaginary number, and 2i times negative 6i, which gives us negative 12i squared. I squared is equal to negative 1. And negative 12 times negative 1 would give you positive 12. So we wind up with a real number, positive 12, and an imaginary number, positive 6i. So this is a complex number. So we can multiply a complex number by a real number or an imaginary number, and the product will wind up being a complex number. Now let's discuss the imaginary unit a little bit further. The imaginary unit is equal to the square root of negative 1. I is equal to the square root of negative 1. So I squared is equal to the square root of negative 1 times the square root of negative 1, which is equal to negative 1. But the imaginary unit goes through a cycle up to 4. So I cubed is equal to the square root of negative 1 times the square root of negative 1, which would be equal to negative 1 times the square root of negative 1. And this would be equal to negative I. So I cubed is equal to negative I. And then I to the fourth is equal to the square root of negative 1 times the square root of negative 1, which is negative 1, times the square root of negative 1 times the square root of negative 1, which is negative 1. Negative 1 times negative 1 is positive 1. And then once we get to I to the fifth, I to the fifth is equal to I to the fourth times I. So that would be 1 times I. So I to the fifth is equal to I. So every 4, it repeats itself. Now, for most complex numbers, you'll only wind up dealing with I squared, but I wanted to make sure we reviewed this briefly in case your instructor gets creative. But let's take a look at the FOIL method in case we were asked to multiply two complex numbers times each other rather than a real number or imaginary number being distributed to a complex number. So the FOIL method is a technique used to remember the steps required to multiply two binomials. Remember, a complex number is a binomial. So if we are multiplying two complex numbers, we will need to know how to multiply two binomials. So FOIL stands for first. So you multiply the first term in each set of parentheses. So if we had a plus b times c plus d, the first thing you do is a times c, which is ac. Then the O stands for outside. So you're multiplying the outside terms, a times d, which will give you ad. So after the first two steps, we've multiplied the first term in our first binomial times each term in the second binomial. And now the third term inside means you're multiplying the inside terms. So notice now we are taking the second term in our first complex number, and now we are about to multiply it times each of the terms in the second binomial. So again, I in FOIL stands for inside, which means we're multiplying the terms on the inside. So b times c gives us bc. And then the L in FOIL stands for last, which means we're multiplying the last term in each binomial, which will give us b times d, which is bd. So we wind up multiplying the first term in the complex number times each term in the second complex number, AC and AD. And then we wind up multiplying the second term in the first complex number times each term in the second complex number, giving us BC and BD. Let's take a look at an example. Let's say you were asked to find the product of 2 plus 3i times 4 plus 5i. The first thing you want to do is use the FOIL method to expand the expression. So F stands for first, which means we're multiplying the first term in each complex number. 2 times 4 gives us 8. The O in FOIL stands for outside. So now we're multiplying our 2 times the second term in the second complex number, which is 5i. 2 times 5i gives us positive 10i. Now we're going to take our 3i and multiply it times 4 and 5i. So I in FOIL stands for inside, multiplying the inside terms. 3i times 4 gives us 12i. And then the L in FOIL stands for last, meaning we're multiplying the last term in each complex number. 3i times 5i gives us 15i squared. So after we use the FOIL method, we are left with 8 plus 10i plus 12i plus 15i squared. So before we can simplify this to a complex number, we first want to replace this I squared with its equivalent, -1. When we do so, 15 times -1 gives us -15. And now we have 2 real numbers and 2 imaginary numbers. So the third step, we combine the like terms. 8 minus 15, our real number, plus 10i plus 12i, our imaginary number, giving us a final answer of 8 minus 15, which is -7, plus 10i plus 12i, which is 22i. So that is how you go about multiplying complex numbers. Let's have you try a few practice questions. Question number 1. Find the product of 6 times -3 plus 7i. Question number 2. Find the product of -4i times 5 minus 8i. Question number 3. Find the product of 8 minus 2i times -3 plus 4i. In question number 4, find the product of -9 plus 3i times 2 minus 6i. Pause the video, answer these questions, and then press play when you're ready to begin. Question number 1, we're asked to find the product of 6 times -3 plus 7i. So step 1, distribute the 6 to each term in this complex number. 6 times -3 gives us -18. 6 times positive 7i is positive 42i. So the answer to question number 1 is -18 plus 42i. Question number 2, we're asked to find the product of -4i times 5 minus 8i. Step 1, distribute the -4i to each term. -4i times 5 is -20i. -4i times -8i is positive 32i squared. And now we want to replace I squared with -1, giving us 32 times -1, which is -32. So -4i times 5 minus 8i is equal to -32 minus 20i. Question number 3, You were asked to find the product of 8 minus 2i times negative 3 plus 4i. So since we're multiplying two binomials, we'll need to use the FOIL method to expand the expression. 8 times negative 3 is equal to negative 24. 8 times positive 4i is positive 32i. Negative 2i times negative 3 is equal to positive 6i. And negative 2i times positive 4i is equal to negative 8i squared. So now we'll want to replace I squared with negative 1, giving us negative 8 times negative 1, which is equal to positive 8. So we have two real numbers, negative 24 and positive 8. So we'll be combining those. And we add that to our imaginary numbers, 32i and 6i. So the final answer is negative 24 plus 8, which is equal to negative 16, plus 32i plus 6i, which is 38i. So we get negative 16 plus 38i. In question number 4, we were asked to find the product of negative 9 plus 3i times 2 minus 6i. So the first step, we'll use the FOIL method to expand the expression. So negative 9 times 2 gives us negative 18. Negative 9 times negative 6i gives us positive 54i. Positive 3i times 2 gives us positive 6i. And positive 3i times negative 6i gives us negative 18i squared. So now we'll want to replace I squared with its equivalent, negative 1, giving us negative 18 times negative 1, which is positive 18. Step 3, combine the like terms. Negative 18 plus 18 will wind up canceling each other out since they equal 0. And we combine 54i and 6i. 54i plus 6i is equal to 60i. So the final answer, negative 9 plus 3i times 2 minus 6i is equal to 60i.